So what's up next is 3-4. So I have a study paper there in your hands for getting ready for 3-4, and we'll just fill this in together, and I'll just sort of explain what this stuff is about from past, present, and future. The 3-4 reading is going to have 7 points. They're all fill-ins. There are going to be a couple postulates. There's a couple definitions, but it's all fill in the blank for stuff. It's always good to know the names of anything that has a name in terms of a postulate or theorem, and it's always good for definitions and stuff to be ready to just fill in blanks. But 1 to 7, 7 fill in the blanks from reading 3-4. Then everything else is coming out of a combination of the last couple days. So anybody for 8, can you give a shot at a definition for collinear? Let's try this. What one word would be unavoidable in this answer?
Line.
Line. Okay, so collinear is based on the word line, and it's not just the word line, but we need to structure a sentence around the word line. So here's my answer for 8 is, there is a line that contains all the points. So a set of points would be collinear if there is a line that contains all the points. So there's a set of points. There's only 2 in that set. Is that a collinear set?
Yes.
Yes. Would every set of 2 be collinear?
Yes.
Yes. Here's a third point. Still collinear? Yes, because there's still a line that can get them all. Would every set of 3 be collinear? No, because what could I have done?
You could put it
Like a triangle kind of thing. Now that's not collinear anymore. But collinear, the idea is there is a line that contains all those points. Having 8 on the paper gives you a pretty good shot at 9. Anybody, can you take a shot at what makes a set of points be coplanar?
A set of points that are all in one
We could just use ditto marks and just trade the word line for the word plane. There is a plane that contains all those points. 10 we had last chapter, we had this chapter, we'll continue to have in the future. Somebody get me line postulate, what that's about?
For every 2 points, there is exactly 1 line that connects them.
That does it. We need to mention 2 points, and then we've got to get the exactly 1 line thing going on there. For every 2 points, there's exactly 1 line that contains both points. If you leave out the word exactly, that's starting to matter to us. So we've had that conversation several days in a row. It's different if I say I have 1 than if I say I have exactly 1. The exactly gives you a little more clarity to what that sentence means. It's not more, it's not less. It is exactly 1. So that's 10. 11, the title gives you a tip of how you should structure these sentences. It's a 2-point question because there's 2 sentences. And because of the name, one of the sentences is going to start with the word plane, and the other sentence starts with the word space. So planes contain at least, what's the magic number for the plane sentence?
3.
3, and then 3 what?
Points.
Points, and there's a word that goes in that gap. Non-collinear. Planes contain at least 3 non-collinear points. At least 3 means 3 or more. 3, 4, 5, millions, billions, trillions, 3 or more. But planes, any plane has to contain at least 3 non-collinear points. The non-collinear matters anytime in geometry you're dealing with 3's. This is usually a different scenario of what's going on than this. If I draw these 3 points, can I touch these 3 with a plane? Yes. Once I do I have any other options, or is that it? To touch them with a plane. Look, here's my 3 points. I touch them with a plane. Can I really move that and still touch all 3 points still? Not really. Okay, so if I have 3 non-collinear points, I've got a way to get them, and once I get them, I got them. I can't be moving around. If the points were in a line, Is there more than one way I can like situate this folder in space and still touch all those points? Yeah, it could be horizontal, it could be vertical, I could go diagonal the other way. I could sit here and touch this, all different sort of orientations in space. There's a lot of planes that could get these points, but there's only one plane that can get those. Well, anyway, back to 11. Answer is planes contain at least 3 non-collinear points or non-collinear matters. Space, it's a similar sentence. Space contains at least, but a different magic number. 4. It's still points, but what's the describer for that? Non-coplanar. Space contains at least 4 non-coplanar points. 13, we had a conversation yesterday on this. If I don't drop you a number, specifically drop you a number, I mean those points might be the same. If I dropped you a number, they have to be different. And I don't remember which way I asked the question today on the quiz, but you're filling in the blank with same or different, depends on how I set you up. Flat plane postulate, can anybody do it? Okay, so flat plane postulate says if 2 points of a line lie in a plane, then the line lies in the same plane. If 2 points of a line lie in a plane, the line is in the same plane. So if I'd want to illustrate that on my plane, the first thing I would want to draw on here would be, no, earlier in the sentence, 2 points. So there's 2 points there. If 2 points of a line are in a plane, the line I drew has to be in the same plane. Once I draw you these 2 dots on the plane, if I connect them, do I have to stay on my plane with a straight line? Or can I leave my plane and come back in somehow and connect those with a line? I have to stay there. It's a postulate. So why? It just is. Okay. If you're trying to overthink these postulates, don't. They just are. It should just be a thing that you read it and think, well, that just like has to happen. There's not an explanation for it. If I draw 2 points in a plane and I connect them with a line, that line has to stay on the plane. That's called the flat plane postulate. It's called that because planes are flat. There's not a big mystery as to how they named these either. But that's what that concept is. If 2 points of a line are in a plane, the line has to be in the same plane. 15, 16, the plane postulate, they start with numbers. What was the key number for planes again? 3. So there's 2 sentences that start with 3. And they're building off of this idea again. These 3 points are collinear. These 3 points are true. But what's the opposite of this? Non-collinear. So we're going to build 2 sentences that work off the word 3. So here's the sentences. 3 points lie in at least one plane. 3 non-collinear points lie in, what do you think on a phrase change? Exactly one plane. So 3 points lie in at least one plane. 3 non-collinear points lie in exactly one plane. Because if I just tell you there's 3 points, you don't know if it's this or this. So like how many planes can touch these all at the same time? Exactly 1. How many planes can touch these? An infinite amount. So if I just tell you I have 3 points, it's at least one plane. You don't know if it's one or maybe lots. 3 non-collinear points have to be lying in exactly one plane. 17 starts off with a small but very important word, which is if. If 2 planes intersect, the intersection is a, what do you think? Line is correct. So I've got cardboard for this, and I broke this out another day. Here's 2 planes intersecting. So intersect, what's the word intersect mean?
Go through.
It has to touch both of them. It's what's in common. Okay, so if I look for anything that's on this cardboard and this cardboard, something that's on both planes, once I do the intersection of planes, they're touching in this seam right here where they're touching each other. That's a line. If two planes intersect, the intersection, what's in common, has to be a line. That's what that postulate says. Two planes don't have to intersect. How can I have these not intersect? What's another word that exists in nature? No. If they don't, how can I have these planes not intersect each other? Like this is them intersecting each other, making a line. How can I have these not make a line?
Just like these.
Go, Justin. If they were parallel, okay? If I did these planes like this, then what is their intersection? A word from last chapter. They don't intersect at all. So what's the intersection?
Empty set.
Empty set. Okay. The planes don't have to intersect. They could be parallel, or they could be intersecting. Like that's our two options. Could two planes intersect like that, and they actually have in common a whole plane?
Yeah.
In theory, yes, but not if I use the word two. Because two means they have to be
Exactly.
different. Okay, so if I said to you, this is a plane, this is a plane, what could they do for intersecting? And I didn't use a number there.
Anything?
They could be this, they could be doing this, or they could be doing that. But if I say to you, these are two planes, that's not a choice anymore. When I say two, they've got to be different. So it's either parallel or they intersect. This postulate's telling you if they intersect, if they're doing this, and there's two of them and they're different, that has to make a line. But the if sort of like implies, the if is an important word. It's like, if I go to the mall tonight, I'll be at the movie theater at 8. Should you go to the movie theater at 8 and know you're going to see me there? No. If I'm in the mall, that's where I'll be. But like maybe I'm not at the mall. Okay. This is telling you if two planes intersect, this is the way it has to happen. But maybe they're parallel, maybe there's other scenarios. But if they intersect, it makes a line. All that to say, the word if matters to start that sentence, because it does. Let's go to 21 before we come back to 18. 21, I had given you an explanation of determine a while back. They used it in a homework, a ways. I think the homework asked you questions like, do 2 points determine a line? And that answer was yes, because it was able to do what it was needing to do. I think they asked you if 2 points determined like a ray, and that answer was no. Why did 2 points not determine a ray? Do you remember?
Because it could just not be a ray.
Maybe.
Because you need that like third point to like continue it.
Maybe. This determines a line because, can anybody explain what determine means?
I thought you were guessing first.
All right. Let me give you the answer and then we'll double back. So determine means there is a figure that contains all those points. It also means there's only one way to position that figure. So there is a figure that contains all those points, and there's only one way to position that. So if I go back to my 2 points, can I draw a line that gets them both?
Yeah.
Yes. Once I commit to that, is there any other line I can draw that wouldn't go right stacked on top of the one I already have?
No.
No, that is the only way to do that. If I try to say if 2 points determine a ray, can I draw a ray that touches both of those points? Yes. There's one way that I could draw a ray that gets them. Is that the only ray I could have drawn?
No.
How can I draw another ray that gets them?
No ray, go the other way.
Go the other way. I could start here and go that way. What's another way I could get both of them with a ray? I could start over here and go get them. There's a lot of ways I could draw rays. So 2 points don't determine a ray. Another way I could, I guess, say this is, here's 2 points, I'm going to connect them with a line. Are you positive what line I'm about to draw you? Yes, this is my only play. If I say to you, here's 2 points, there's going to be a ray, get them both. Are you sure what ray I'm going to draw you? No, because I might do something like this. 2 points. Do those determine a segment? No, because other than doing this, what else could I have done? Start farther down and go through and stop. Or maybe I even keep going. There's a lot of segments I can draw that get them both. It's not necessarily just that one choice. There's lots of choices. These 3 points don't determine a plane, because although a plane can touch them all, a plane coming through my board like this touches them all just as well. So does a diagonal plane, so does an uphill diagonal plane. There's just too many choices. Do these 3 points determine a line? Or a plane, excuse me?
Yes.
Yes, because there's only one plane that can get all 3 of those. But anyway, 21, there's a figure that exists that contains all those points, and there's only one way to position it. That's our definition for what determine means. So back to 18 to 20, there's 3 ways in the reading that they talked about being able to determine a plane. One of them's already on my board. One of them already made the quiz in one of the sentences. Anybody have a thought on something that can, like 2 points can determine a line? Can somebody tell me something that can determine a plane? 3 non-collinear points is perfect. Here's another choice, is 2 intersecting lines. So when I'm talking about lines, I'm usually going to hold pencils. So what would 2 intersecting lines look like? Yeah, make an X. So if I make an X with my pencils, can a plane touch all of that? Yes. Once I commit to this being where it goes, if I move it around, do I have other choices, or do I just have the choice of lay it down here? Just lay it down there. So 2 intersecting lines determines a plane. The third choice is if you have a line, one line, and 1 point that's not on the line. You could be my assistant. So if I'm going to do a line, and I'm going to do a point that's not on the line, can she touch all that with that folder? Yes. Once she does, can it be moved, or is she stuck? She's stuck. She can only do that by going like that. That's it. That's your only choice. So if you have one line in conjunction with a point not on the line. This always reminds me of the Partridge in a Pear Tree song for some reason. The like, I forget how that one even goes. They count you down, 5 of this, 4 of this, 3 of this, 2 of this, and a partridge in a pear tree at the end. I don't know if that helps you at all to remember the answer to this, but it's doing a countdown. 3 non-collinear points, 2 intersecting lines, and a line and a point not on the line. It reminds me of the phrasing of that. Anybody know that song, what the other even lines are? 3 something?
2 turtle doves, 3 French hens.
Okay, so you're like 3 French hens, 2 turtle doves, and a partridge in a pear tree.
Yeah.
So this you've got 3 non-collinear points, 2 intersecting lines, and a line and a point not on the line. I don't know. That helps you, great. If not, whatever. But I can't help but think of that song, but I'm not going to sing it because that wouldn't help anybody. But again, that answer was 3 non-collinear points, 2 intersecting lines, and the last choice was 1 line and 1 point not on the line. Question about what's going on with any of that.
What was 17?
17 again is if 2 planes intersect, the intersection is a line. If 2 planes intersect, the intersection is a line.
What was 21?
21 is there is a figure that contains all the points, and there's only one way to position that figure. Again, trying to hit you with some key reminder words. The titles give away the content on a lot of this stuff. So again, plane, space, postulate. Start a sentence with plane, start a sentence with space. Flat plane postulate, you've got to be mentioning planes. Plane gets mentioned in that twice. If 2 points of a line are in a plane, the line is in the same plane. 15, 16 is number based, so planes have to do with threes in all these operations. Start 2 sentences with threes. 17, you want to mention intersecting and planes because that's how the thing got its name. Maybe that little bit of stuff helps. Question about what that's about. Homework will be 59. 59 works of 1 to 16. Let's go to 55 and punch through some answers to 55 now because we still have like 10 minutes left. I take that back. Let's go to 50. Yeah. Okay, so 50 is kind of like a preview of some things that were to come that by now have come because we're up to like 3-3 now. So number 1 says, hold your arm in front of you. You're considering a point on the tip of your forefinger. You're also considering another point in some corner of the room. So you're considering 2 points. Anytime you're considering 2 points, no matter how they set up that story, how many lines contain 2 points? 1. What is that called?
Line postulate.
That is the line postulate. So number 1 is previewing for you, hey, the line postulate is coming in this chapter. Any 2 points are on a line. 2, they say, take your book or a piece of stiff cardboard. Can you support it in a fixed position on the sharpened ends of 2 pencils? So when they're talking cardboard, what are we talking about? Geometry term?
Plane.
Planes. Does 2 have to do with planes? No. So when they ask you, can you take 2 pencils and balance your book on there forever? That answer is no. I had a kid once try to tell me he could, and I told him to go ahead. And he spent the rest of the period trying to build like a support system for his book on 2 pencils, and needless to say, that failed. You can't do it. It would violate Euclid and all his laws. We'd have to burn all the books and start over. If you have 2 points, there's no way you're going to take 2 points and permanently build like a solid structure for things to be on. It just doesn't. They ask, what's the minimum number of pencils you would need to support your book in some sort of a permanent way?
3.
3. What thing is that now? Threes and planes.
Planes.
There's a plane space postulate that does that. What else is doing that? Threes and planes lately. Other than plane space. The plane postulate is also talking about that. 3. Can 3 points be on a line means, is it possible? Is it possible 3 points are on a line?
Yes.
Yes. Here. Must they means, are we certain? Does it have to happen?
No.
Must 3 points be on a line?
No.
No, because triangle. 4, it doesn't really matter the setup that they're giving you, but they're having you envision 3 points. 3 points, is there a plane that can get them?
Yes.
Yes, always. Any 3 points have to be in a plane. That's again tapping back into the plane postulate. Any 3 points have to be in at least one plane. 5, they ask you minimum number of points to determine a plane. So again, we're back to the magic number of planes,
3.
3. Will 3 points always determine a plane?
No.
No, they have to be
Non-collinear.
non-collinear. If it feels like this homework is repeating everything I already talked about on that other paper, it's because this homework repeated everything that was on the paper that we filled in. They were trying to set you up for the chapter. 6, they don't have in mind that you try to write with words what lines you're missing. They have more in mind that you try to draw what's missing. 7, they have more in mind that you try to draw what's missing and complete some dotted stuff. Let me come back to that in just a minute if there's time. Let me do 8 because it's on topic with something I already did today. I already grabbed 2 pencils and I already did this and we already talked about planes. If I have my 2 pencils, what can we do? They are coplanar. How many planes can touch them is what they're asking you.
Well,
Exactly one. So 8 is that. It's one of the things that was in the reading and on the next quiz. B, they ask you or for 9, they ask you what looks like a better book. I think pretty clearly B is a better book drawing. On 10, they ask you what looks more like a cup. I think 10, cup A, definitely looks better. Then they ask you for B, what does this suggest? Your point of view, you look at things, really determines what they look like. Did anybody figure out 12? 12's an idea we haven't run into yet this chapter, but will.
I don't know if this is right, but like, it's like exactly 4 feet, and when you cut it, you like lose a little bit on both sides. So then it's like,
Where does it go?
just
Well,
like
it's
that
sawdust
way.
now.
There
It
you
still
go.
exists, but it's not in the.
That is correct. The answer to 12 is basically sawdust. Okay, what you have is a 4-foot thing, and you cut it perfectly, and you remeasure the pieces. They are not perfectly going to be 2s. 2 plus 2 does not make the original board of 4. The 2 plus the 2 plus the sawdust on the ground would make the 4 of the original board. If you perfectly cut some sort of board in half, and it started off being 4, it's probably like 1.9999 and 1.9999, and on your floor you've got this tiny little bit of sawdust on the floor, but that's what 12. 12 is sawdust. I'll make reference back to that in a future reading section, because that's going to be something that they're previewing something to come. 6 and 7, brief drawing tip about drawing. I drew you a couple shapes. Here's the best way to draw things that are 3D. Draw the front that faces you. After you draw the front, then what do you think you should try to draw?
the sides,
Disagree.
back.
Why the back?
Because it's like, it's pretty much the same
It's the
thing.
exact same thing. Draw the back, which will always match the front. And once you draw the front and once you draw the back, why are the sides easy?
You just connect them.
You just connect them. So if you had trouble drawing 6 and 7, try to take that tip and do it. Keep your page 50. Draw the front first, draw the back second, because they will always match size and shape, and then draw your connectors.
There's back there, so you can-
50